Okay, so imagine for a second that you're on a truck. Don't question where I'm going with this. Just use your imagination for now and pretend that you're on a truck. This truck. So I'm gonna draw you. There you are. You're hanging outside the truck for whatever reason. And in case you're wondering what kind of truck it is, it happens to be a pizza delivery truck. Because we all know that it's very vitally important to know what kind of truck it is. So, right. Anyways, you're rolling along, everything's fine, you're just delivering your pizza, doing your job. Everything's good, right? Until, bam! You're gonna hit a tree head on. You must be some terrible driver not to see where you're going with this, and that there was a tree right there, and you couldn't see it. But more to the point, to avoid this hitting the tree, you swerve immediately to the right as fast as you possibly can, and then as a result of that, you hit a log. This log. Isn't that great? So, this isn't looking too good for you. Your back wheel just suddenly decides to now pop off as you hit the log. And, even worse, you fall right off a cliff. Yeah. But luckily for you, you manage to land onto another parcel of land. But unfortunately for you, you have to pay some consequences. For now, your wheels have kind of sunk into this pile or parcel of land. Right. I tried to make that straighter, but it didn't work out. But now you're just kind of sliding to a stop here, and you're stranded on this cliff. Isn't that great? So now, you being the responsible driver that you are, you kind of step out here, and you take a look at the damage that's been done. Lucky for you, there hasn't been too much damage to the truck, other than the wheels, of course. But, unfortunately for you, you're on another cliff. Right here. And there is hardly enough space for your wheels, or your half wheels, to stay on the parcel of land, but at least you didn't fall off, right? Again. So the cliff that you happen to be stranded on is trapezoidal. Kind of like this, right? So, now I know what you're thinking. How in the world does this relate to mathematics or geometry in any possible way, shape, or form? Well, if you look at this diagram that I've been drawing for you for the past 2.5 minutes, and you take out this truck, you take out you surveying the scene, and voila, you have problem number 17 on page 812. So, now what you have here is your tires, which each have a diameter of 3 inches. The tires are represented by semicircles because they're obviously sinking into the land. And the parcel of land that you are on has a lower base length of 6 inches. And in addition, the height or the altitude of this trapezoid is also 6 inches. I know that these are on the other side, but I just felt like switching things up. Okay, so now with this information, the problem asks you to find the area of this entire figure. Now, if you're stranded on a cliff, I'm sure that you have, or most of us have, better things to do than to sit around and calculate the area of this figure. But hey, to each their own, right? Okay, but now, again, as I said before, you have to find the area of this entire thing, and the book asks you to round to the nearest tenth. Now, being the math nerd that I am and demanding accuracy all the time, I wish to keep my answers in exact form. As in, like, having no estimations. But, and you should do the same thing. But since the book wants you to do nearest tenth, let's make the book happy, and do nearest tenth as well. So, with this in mind, let's go, and let's start off with these 3 semicircles here. So, again, they each have a diameter of 3 inches. So, using this, we can easily find each semicircle's radius, which is obviously just half the diameter. So, the radius is 3/2 inches. And so, in order to find the area of one of these semicircles, we can just use the area formula for a circle, and then divide the result by 2, because a semicircle is half a circle. Makes sense. So, the area is pi r squared, that's an r, divided by 2. because this is a circle and this is half a circle. And I'm going to rewrite that right away, actually, as this pi squared times 1/2. Same thing as dividing by 2, multiplying by a half, right? So, if you plug in your r, you get pi times 3/2 quantity squared times a half. And then you can rewrite that as 9/4 times 1/2 times pi, or just 9/8 pi. And this is, whoa, look at this, 8. And this is just the area of one of your 3 semicircles here. And since you have 3 of them, you can just multiply that by 3, and you get 27/8 pi inches squared for the area of each of these 3. Or not each of these 3, rather the combined area of the 3 semicircles. And you can rewrite that as 3 3/8 or 3.375. Again, mathematics likes equivalency, so just as long as your answer remains consistent and equivalent, then you are good to go. Let's just get rid of all this. Okay, so moving on to the trapezoid. Now your trapezoid has a lower base length of 6 and a height of 6. So in order to find the area, or the fastest way to find the area is using the formula. And you need both the lower base and the upper base. But the upper base is comprised of just the diameters of each of these 3 semicircles. And each of the diameters is 3. So the upper base the upper base length is just 3 times 3, or 9 inches. So I'm going to call that base 1. And you can see where I'm going with the base 1, right? Because the area formula for a trapezoid is just 1/2 times the height times quantity, base 1 plus base 2. Simple enough. So your second base is 6, because this is the lower base angle. Why do I keep saying angle? The length. And the height is also 6. So just plug stuff in. Plug it in, plug it in. Okay, never mind. 1/2 times 6 times 9 plus 6 is the area of this trapezoid. And then simplifying further, that's a times sign. 3 times 15 equals 45. So, the area of this entire figure is simply just the area of this trapezoid plus the area of these 3 semicircles. Because the area of any closed figure is just the area of its components added together. I mean, it makes sense. So, just get rid of all of this. You have 45 inches squared, mind you. Don't forget your units. Inches squared as the area of this trapezoid plus this, which is the area of your 3 semicircles here. So, if you want the exact answer right away, then you're already pretty much done. Just 45 plus, I'm going to do a mixed number here, 3 3/8 pi inches squared. Now, if you happen to like the book, and this is the area of the entire thing, if you happen to like the book, and if you want to please the book, then you can go ahead and plug it into your calculator, and you should get 55.6 inches squared. And you're done. Wasn't that fun? So you've passed some time now as you wait for your insurance company to answer your call, since you've been calling and they haven't been responding. So I hope you've enjoyed watching this video. You can leave a thumbs up and subscribe if you want to watch more stuff. And have a nice day. Bye.